All right, so last time we looked at parabolas. Okay, today we're going to look at an ellipse. Okay, again, this section, it's 6.3 in your packet. If you want to look at it in your book, it's 9.4. Okay, all the conic sections in your book are done in one big section. All right, so when we define a circle, okay, we talked about that, I think, back when we did a parabola. A circle is a collection of points that are all equidistant from a center point. Okay, very easy to define. A parabola was a little harder. It was a collection of points such that when you add the distance from, what was it, a point on the parabola to the focus and the same point to the directrix, those distances come out equal. So now you don't add them, they come out equal. Well, an ellipse is a little different. You're going to take two distances and add them up. In a minute, I'll show you what the two distances are. And when you add up these two distances, it's always going to come out to a constant. And these fixed points that we're talking about, these are called the foci. Okay, so I'll put that back up in a second. I'm going to show you a picture so you can kind of see the two distances that I'm talking about. Okay, so there's an ellipse. Okay, in that ellipse, B and C are the foci. Foci is the plural of, does anybody know what word I'm talking about? Focus, yeah. We don't say focuses, we just say foci. So B and C are your two foci. E is just in a point on the ellipse I can move anywhere I want. Okay. What I'm going to do is I move point E, I'm going to add up the length of segment EB, the length of EC, and those two numbers are always going to add up to 17.3. Okay, so you can change the length of the segments. EB and EC are always changing length. But when you add them together, you're always going to get 17.3. In this particular ellipse, it's not always 17.3. In fact, I don't think any problem we do today, we're ever going to find what these distances add up to. It's just what the definition is. Okay, so the way you could make an ellipse, if you had, kind of like I've done it on the bulletin board, if you take two push pins, okay, put them in at points B and C, and then take a loop of string. Okay, and put that loop over the two push pins, and then pull it. Yeah, Mr. Sandin did that. Yeah, pull it taut, and then just drag it around the circle, and you'll get an ellipse. All right, so you need those two fixed points to make an ellipse. Versus a circle, you could do with just one push pin. Just take a piece of string, attach it to the push pin, and then just go right around, keeping it pulled tight. Okay, so any questions on an ellipse? So that's what it looks like, kind of like an oval. All right, it's kind of what it looks like. Okay, so there's a few different things I've labeled in this picture, but basically I'm showing you the same thing I just did on the other screen. If you take the distance from any point to the first focus, take the distance from that same point to the second focus, and add those two distances up, you're always going to get a constant. A few other things I have labeled, which I'll define. We have a major axis, okay, running horizontally in this case, a minor axis running vertical, and V1 and V2, which are your vertices. Okay, we'll define each of those terms. Okay, the line that goes right through the foci, that's the major axis. Okay, the major axis basically goes through the ellipse the long way. That's how you can think of it. It goes through the ellipse the long way. So if your ellipse was rotated 90 degrees, and it was more of a vertical ellipse, then your major axis would be up and down. Okay, so whatever direction the long way is, that's the major axis. Right, so if you draw in a segment that connects the two foci and you find the center, find the midpoint between those 2 points, that's your center. It would also be the same if you drew in a segment from V1 to V2 and found the midpoint there as well. That's the center. Okay, so we didn't have these terms when we talked about a parabola. Okay, when you do parabolas, there's no such thing as a major axis. There's no center. For a circle, there's a center. Okay. Another term is the minor axis. Well, the minor axis, first of all, goes through the center. It's perpendicular to the major axis. And that's how you define it. It goes right through the center, perpendicular to the major axis. Parabolas don't have a minor axis either. Okay, so these are all new terms. Parabola did have a vertex, but it only had one. Okay, an ellipse has two. Right, so if you draw in your minor axis and you look where it crosses the ellipse, those are your vertices. Okay, so there's my minor axis. V1 and V2 are the 2 points where that axis crosses the ellipse. Any questions on any of those terms? Okay, we're not going to derive the equation like we did for a parabola. I think there were four basic equations for a parabola, opening up, down, left, or right. We went through and derived one of them, but for the ellipse and the one we do tomorrow, the hyperbola, we're not going to derive the equations. So I'm going to start you guys off with the basic equation, which always has the center at the origin. Okay. In your packet, you've got the table, but I would, if you're making a reference sheet, I don't know if I would put this formula on it, because this is a special case where the center is at the origin. Okay, in a little bit, I'll give you the formula where the center can be shifted from the origin. Okay, so this is the case where you get the center at 0, 0. The foci are going to be at negative C0, or C units to the left, and then C0, or C units to the right. So they're going to be spaced symmetrically around the center. Okay, the major axis is going to be horizontal. The vertices are always a little bit further out than the foci. The foci are inside the ellipse. The vertices are right on the perimeter of the ellipse. And those are spaced symmetrically, A units to the left of the origin and A units to the right. Okay, does everyone have what's on the left? Okay, in this equation, if you're looking at your packet, it's page 390. The equation is x squared over a squared plus y squared over b squared equals 1. Now, once you fill in numbers, the only way you know which number is a and which number is b, looking at the denominators, is this fact right here. A is always bigger than B. A is always bigger than B. And B is greater than 0. So this means A and B are always positive numbers. If we had a negative between here instead of a plus, we'll talk about that tomorrow. Just changing that plus to a minus gives us a different shape. And here's the relationship between A, B, and C. Kind of looks like the Pythagorean theorem, but it's not. Okay, C squared equals A squared minus B squared. So if you look at the formula, do you see C anywhere in the formula? No. C's not there. But a lot of times what they're going to do is give you the coordinates of the foci. So you're going to know C. Right? Then they might give you the coordinates of the vertices. So you're going to know A. But the problem is you need B in the formula. Well, if you know A and C, we can easily find B. Sometimes this is helpful. Okay, the book mentions this, finding your intercepts to graph an ellipse. Maybe. Anybody think where this wouldn't be helpful? Is there any case where that wouldn't really apply? Yeah?
If the ellipse didn't have x and y intercepts?
Yeah, it's possible you just have an ellipse in quadrant 1. It doesn't cross any axis. All right, so if your ellipse doesn't cross an axis, you're not going to be able to find the x and y intercepts. Okay, so here's kind of the three important facts to know about A, B, and C. Okay, A is the distance from the center to the vertex. Okay, B is the distance from the center to where the minor axis intersects the ellipse. Helpful if you're trying to make a sketch. So B is the distance from the center to where the minor axis crosses the ellipse. And C is the distance from the center to the foci. If you can remember those three things, that's what's going to be helpful when you have to sketch. Or if you're given a sketch and they want you to find A, B, and C, just looking at the picture. It's all distances, A, B, and C. Okay, I wrote it out kind of long way on the board here, but on the whiteboard I just kind of condensed it, what A, B, and C are. Okay, kind of the nice thing about A, B, and C in an ellipse is it's all very visual. Okay, you can measure all these distances and see where they are. When we talk about hyperbolas tomorrow, I think B in particular is not something we're going to be able to or talk about how to visualize. A and C we will, but not B. Okay, everyone have what A, B, and C are? All right, so let's take a look at this problem. All right, so your center is 0, 0. Your focus is 3, 0. Your vertex is negative 4, 0. Okay, they want you to find the equation. Well, for this problem, you can assume the equation is going to be just like the form right here. Okay? But we don't always know which way the major axis is going to run. And I'll show you how you can graph these points and figure that out. All right, so first thing we want to do is figure out what A, B, and C are. Okay. I think we're going to be able to get two of the letters right away, but then the one that we really need for the formula, we're going to have to use a calculation to figure out. All right, let's start with the vertex. What does the vertex tell me? You can either go back to all these bullet points that I have about it and look at what the vertex tells you, or you can just try to remember the general idea. A is the distance from the center to the vertex. So what do we know by looking at where the center is and where the vertex is? Yep.
A is 4.
Yep.
C is 3.
Right. And C is the distance from the center to the focus. Okay, we also know that if 3, 0 is a focus, negative 3, 0 is a focus. If negative 4, 0 is a vertex, then 4, 0 is also another vertex. All right. So now we have to find B. Okay, to find B, C squared equals A squared minus B squared. squared minus b squared. Okay, just fill in, solve for b, then we can write our formula. So we have 9 equals 16 minus b squared. Bring 16 to the other side, you're going to get negative 7 equals negative b squared. And this is why a always has to be bigger than b. If it wasn't, you'd run into a problem in this formula. Okay, you'd be trying to take the square root of a negative. All right. So as long as a is always bigger than b, then the negative should cancel out. We should be fine. All right, so b equals 7. Square root of 7. I'm not sure it's really important to find b. We probably could have left it at b squared equals 7, because b squared is what you need in the formula, and a squared. Right, so let's write our equation. All right, so it's x squared over a squared plus y squared over b squared equals 1. And that's it. That's the equation of your ellipse. Any question on that? Okay, once we talk about the major axis going in the other direction, okay, my hint is going to be, look where the bigger number is. Wherever the bigger number is, that's which way the major axis goes. So if the bigger number is under x, major axis is horizontal. If you put the bigger number under y, then the major axis becomes vertical. Okay. All right, so again, just by looking at this, bigger number is under x. I already know the major axis is horizontal. So I'm going to write that down. Right, some of the other things you should mention when you discuss an ellipse. What's the center, the vertices, and the foci. We've only talked about an ellipse having one point as the center right now. What's going to be the center of our ellipse? We haven't talked about anything else yet. No. 0, 0. You'll know when it's not 0, 0. Okay, the numerator will look a little different. Okay, what's Andrew? What's a here?
No, 5.
5. Good. What other letter, Silvio, can I find directly? B or C?
C. Oh wait, no,
B,
B.
right? The two letters in the formula are a squared and b squared. So what's b?
B would be 3.
B is 3. Now we can find c, and c is important because it's going to tell us where the foci are. Okay, so let's find c. Justin, what is my formula to find c?
C squared equals a squared minus b squared.
Yep. So c squared is going to equal 25 minus 3. 25 minus 9. So c squared equals 16, which means c equals 4. All right, so now think, your center is at 0, 0. Your foci and vertices are going to be to the left and to the right of that. Okay, so let's start with the foci. We know how far away the foci are from the center. We just have to write it as a coordinate. Okay, so Sam, what are my two foci going to be?
Negative 3, 0, and 3, 0.
Okay, so what letter measures the distance from the center to the focus?
I thought it was B.
B is going to be your distance from the center to where it crosses the minor axis.
Oh, C.
C. Yeah. So you had the right idea, just the wrong letter.
Yep.
So what's going to be our foci?
Negative 4, 0, and 4, 0.
Yeah. So if you want, you can just write it like that. Or you can write it the way Sam said. 4, 0, negative 4, 0. vertices. Oops. Where are our vertices going to be? Yep.
At -5, 0, and 5, 0.
Yep. A is the distance from the center to the vertex, and they're going to be to the left and to the right of it. So you're going to keep the y value 0. You're going to go left 5 and right 5. Okay, and I think that's pretty much everything we'd want to mention. Get the major axis, the vertices, the foci, and the center. It's good. Any questions on that? So that's how you discuss an ellipse. Just describe those 4 things. All right, so this is going to be the case where we're going to take our ellipse and we're going to turn it 90 degrees. So it's going to be the y-axis is going to become the major axis. And now the foci are going to be above and below the center. Okay, so everything's going to line up vertical now instead of horizontal. Major axis is y-axis. And the vertices are going to be A units above and below the origin. Okay, and I already described this earlier a little bit, but what's the only difference between this equation and the one I gave you before?
B and A.
Yep. Yeah. You're just switching where B and A are. A is always the larger number. When we talk about hyperbolas tomorrow, that is not necessarily going to be true. Okay, but for today, A is always the larger number. If it's under Y, major axis is the Y-axis. If A is under X, major axis is the X-axis. Okay, it still has to be true that A is bigger than B, and they're both positive, and C squared equals A squared minus B squared. Anybody have any questions on that? A, B, and C are still exactly the same thing they were before. Okay. No change on that. Right, and if you want to look at this in your book, this is on, let's see. Page 392. It's page 392. Okay, so first thing I want to do is just discuss that equation. Does anybody have any thoughts about what I need to do to this before I can even start to discuss it? It's not ready to discuss yet. It's not written the way it should be.
Divide both sides by 9.
Yeah, you can divide everything by 9. The equation of an ellipse is always equal to 1. If it's equal to 9, well, you got to make it equal to 1. So those cancel out, but if you want to leave something in the denominator just so it visually helps you, it's x squared divided by 1 plus y squared over 9 equals 1. Okay, next, what would it be helpful to identify? This will help us to talk about the vertices and the foci and all that stuff. Yep.
A, B, and C.
Yeah, let's just write down what A, B, and C are. Okay, Orlando, what's A here?
9.
Close, that's A squared.
3.
3. Okay, A is always the larger number. In this case, that's A squared, so you take the square root, we get 3. Tahina, what about B?
1.
Yep. B is the square root of the smaller number, which in this case is 1. And now B isn't really necessary for describing. It'd be helpful for sketching the ellipse, but B is helpful to find C. So C squared equals A squared minus B squared. So we're going to get 3 squared is 9, minus 1 is 8. So C is the square root of 8, which we can reduce, and the book usually will. What does the square root of 8 reduce to? Yep.
2 square root of 2.
Good. 2 square roots of 2. So that's C. Okay, Julia, which way does my major axis go here? Horizontal or vertical?
Vertical.
Yep. Bigger number is under Y. That means that's the direction it goes. Y-axis is vertical. So we got that. How about, Shannon, what's another good thing to describe for an ellipse? Yep, you got to talk about where the center is. What's the center for this ellipse and for all the ellipses we've done so far this time? Yep, 0, 0. Okay, Taylor, what's something else I should describe?
The vertices.
Yep, the vertices.
Plus or minus 3, 0.
All right, so our vertices, let's take a look. So do you want to put the 3 as the first coordinate or the second one?
Oh, the second.
Yeah, so this time the vertices are up and down. They're above and below. So it's 0.
Plus or minus 3.
But yep, she had the right idea. She had the right number, plus or minus 3. So it's 3 units above, 3 units below the origin. And the foci should always be inside the vertices. Okay, the foci should be closer to the origin. C is going to give me the distance from the origin for the foci, and it's 0, positive or negative 2 root 2. If I was going to sketch it, I'd change that to a decimal. That'd be easier. Any questions on that? Yep.
Why is the major axis horizontal?
This case, the major axis is, yes, I meant to put y-axis, vertical. Thank you. Did I say vertical?
Yeah.
I said y-axis, and then I wrote. Thank you. Yeah, major axis is vertical. You always look at where the bigger number is, and that's the axis that it follows, y-axis. Good. Okay, any other questions on that? All right, so when you're doing conic sections, there's a lot of little things you have to make sure you get right. All these horizontal, vertical, where the plus or minus goes. So just got to be careful. All right, so this one we don't have to discuss. They just want us to find an equation for this ellipse. Now, if you look at the way they wrote the problem in the book, this is how they wrote it. But does anything there look a little strange? Anything? It says there's a focus at 0, 2, and vertices at 0, plus or minus 3. Does it seem like they left something out that would be automatic here that they could have written? Yeah?
You would assume that it would be plus or minus 2 for the focus.
Yeah, if there's a focus at 0, 2, there's a focus at 0, negative 2. I don't know why. I don't know why they chose to write the vertices that way and they didn't do the focus that way. All right, but either way, we don't need to know both of them to find A and C. All right, so let's start with A. Okay, Brandon, what's A going to be? Let's see. Yep, distance from the center, which at this point is still 0, 0 to the vertex. Gives me 3. Okay, Marina, what other letter could I find?
You can find C.
C, and that will be 2. And Silvio, last letter I need to find is B, because I need it for the formula, but how do I get it?
C squared equals A squared minus B squared.
Yep. c squared equals a squared minus b squared. Okay, so subtract. You get negative 5 equals negative b squared. 5 equals b squared. So b is the square root of 5. Okay, maybe what we'll do is, let's sketch this one. So we'll find the equation, then we'll sketch it, just to make sure people understand how to do a sketch. So that's x squared, that's y squared. And anyone think they can tell me what it's going to be in my two denominators? Yep.
5 and 9.
So we've got 5 and 9. So it's always a squared and b squared. Just put the bigger number under which way the the major axis should go. How did you know the bigger number goes under y?
Because it's the major axis is vertical.
Yeah, and we'll sketch that so you can see it, but he's exactly right. If you sketch these points, they're all going to line up vertically, okay, on the major axis. Let's make a sketch. All right, so we've got, let's see, foci 2 units above and below the origin. The foci are not actually part of the points that make up the ellipse. They're inside the ellipse. So this is F1, F2. Okay, the vertices are 3 units above and below. And the vertices are points the ellipse it's going to go right through. Call it V1, V2. And what's the other thing that's helpful that we haven't been using a lot is B. That's the distance from the center to where the minor axis crosses the ellipse. So that's going to tell us left and right. So B is the square root of 5, or about, probably about 2.1, 2.2, about 2.2. So we're going to go 2.2 units to the right and to the left. Those 4 dots in green, those are the dots your ellipse is going to go through. Okay, any questions on that? All right, so if we sketch our ellipse, something kind of like that. Any question on the sketch? You're not going to have to do too many sketches, but there might be a couple. All right, so this is a special case about a circle. Basically, a circle is an ellipse. It's just a case where both the denominators are the same. Okay, and what they usually do when they write it as a circle, they take and multiply everything by a squared and move it to the other side. So you have x squared plus y squared equals a squared. A isn't normally the letter we use, though. Anyone remember in a circle what a represents? Yeah, that's your radius. Okay, a is your radius. So when you see the equation of a circle, it's usually x squared plus y squared equals r squared. Okay, and that's all we're going to say about a circle. Okay, it's just a special case of an ellipse. So last thing we're going to talk about is taking an ellipse and you can shift it to a different center point. Okay, the coordinates of the center are going to be h, comma k. So now there's five letters you need to find. You need to find A, B, C, H, and K. This is the equation where your major axis is horizontal. It's x minus h squared over a squared plus y minus k squared over b squared equals 1. How do we know it's horizontal? Well, we put a under x, and a is always the bigger number. Notice where h and k are. H is always in parentheses with x. K is always in parentheses with y. Okay, same condition is true. A is bigger than b, and they're both positive. And c squared still equals a squared minus b squared. In the case where the major axis is vertical, you're basically just switching a and b. Okay, these are all on page 394. These are the formulas I would put on your reference sheet. Okay, because the worst thing that could happen is you use this formula, h and k are both 0, and then they just cancel out and disappear. And you're just left with x squared and y squared in the top. Okay, as always, be careful when they give you the coordinates of the center. You're looking for the number after the minus sign. So if you see x plus or y plus something, be careful with that. Okay, but we talked about that when we did parabolas. Okay, see if we can identify at least 4 of these things, and then the 5th one we're going to have to use the formula c squared equals a squared minus b squared, and then we'll write our equation. Okay, anyone think they can tell me one of those 5 letters up there? Well, Carly, think you could give me? A would be 3. Okay, how'd you get that?
Isn't that the distance from the center?
From the center to where? I'm not saying you're wrong. I see a 3 up here with the focus, but I'm not sure how you got the 3, or there might be some other people that I'm sure how you got 3. But it is a distance. You want to help her out? How did she get 3? I'm sure there's a couple people that are like, I'm not sure how she got 3.
It's the distance from the center of the vertex.
Yeah. And how did you find that distance? Because sometimes that can be kind of tricky. You'd have to use the distance formula. But how come you don't have to do anything like that here?
5 minus 2.
Yeah, these points are lined up straight. One of them is right 2 down 3. One of them is right 5 down 3. Okay. The center and the vertex line up horizontally, perfectly horizontal. So you just have to count how far apart they are. So they're 3 units apart. If you want to use the distance formula to find the distance, you can. I think that's a little overcomplicated. Right? So A is 3. Okay. Any other letters we know?
Wouldn't A be 5 the distance from center to the vertex?
From your center to your well, where's your center? What's the x value?
Oh, okay.
It's not at the origin anymore. All right? So it's been shifted. So I think she is right. Yeah, A would be 3. Yep.
C would be 1.
C would be 1? Perfect. Distance between the center and the focus. Again, these ones are lined up horizontal. They're 1 unit apart. One of them's right 2 and down 3. One of them's right 3 and down 3. 1 unit apart. Okay, so you guys actually gave me the harder ones to find. It's not too hard, but A and C I think are the ones that are a little harder to find. How about H and K? No.
So H would be 2 and K would be 3.
K would be
Well, -3.
-3. Okay, those are given to you directly. H and K. Those are the coordinates of the center. So now we just have to find B. Okay, then once we have B, we can do our formula. Yep, you think you've got B?
2 square root of 10.
Yeah. Any question on how you'd find that? A couple people are looking at me a little bit. So that's your C squared equals A squared minus B squared. In this case, it's 1. A squared is 9. So you're going to end up with the square root of 8. And he reduced it all in one step. So that's perfect. Okay, so now we're going to write our equation. Okay, if you're having trouble deciding where should I put the bigger number, should it go under x? Should it go under y? Graph the focus, graph the vertex. Do they line up horizontal or do they line up vertical? We're going to go for the focus, that's right 3, down 3. The vertex is right 5, down 3. Everything's lining up horizontal. So my major axis is going to be horizontal, so put the bigger number under x. Okay, so that's going to be, it's going to be this one. Lasan, can you fill in my numerator for this ellipse?
2 x minus 2
Yep, that's good.
over 3 squared.
Yep, good.
And then plus, well, 9. And then plus y minus negative 3.
So what's y minus negative
Y
3?
plus 3.
Yep,
Squared over
do you remember what we took the square root of to get that? What was b squared?
8.
Yeah, b squared was 8. And then the last thing, just set it equal to 1. And that's it. That's your equation of an ellipse that satisfies all those conditions. Okay, any questions on that? Does everyone feel like they could sketch that if they had to? You sketch your 2 vertices. Okay. We know the vertices are 3 units above, 3 units to the left and the right of the center. So the first thing I would do is sketch my center. Okay. That would be right 2, down 3. Then I would sketch the foci, the vertices, and that would tell me how long the ellipse is. And then from the center, B would tell me up and down. From the center, you're going to go, let's see, square root of 2 is about 1.4, doubled is 2.8. So you're going to go 2.8 units above, 2.8 units below. And then that'll give you the 4 points to make your ellipse. All right. Let's look at that one. Okay, so I want to discuss this equation. What's wrong with this that's preventing me from being able to tell you where the center is? Because I'm giving you the equation. Usually if you're given the equation, you can look at it, figure out H, K, A, and B right away. Not here.
So it's not really given to you in what we think of as a standard form for an ellipse. So you have to put it into a standard form in order to basically translate it.
Right. We've got to get this written the way we normally write it. This is not how we normally write it. Does anyone remember what we have to do? Yeah?
Move the 4 over to the right side and divide by 4.
Okay, so we're going to move the 4 over. That's definitely a good thing to do. But if we divide everything by 4, even if we divide everything by 4 right now, we're still not going to get it so that we have something squared plus something squared. It's almost like we have a factor here. We've got to get a binomial and another binomial. Moving the 4 to the other side, that's a good first step. Yep. Yeah, factoring out of 4, that'd give us like a distributive property
Right.
with parentheses, but it's not going to give us a binomial squared. Anyone else remember what we have to do? There's a name for this.
You had to do something with the, no.
It's something that you've learned in Algebra 1. Most people don't like to use it. They just prefer to factor or use the quadratic formula. But this is a third method for solving a quadratic.
You complete the square.
Yep, we have to complete the square. And we have to do it twice. We got to do it for the x's, and we have to do it for the y's. Okay, it's two separate parts. All right. And remember the other thing, when you complete the square, your coefficient of the squared term has to be 1. Okay, so the y's, those are ready to be completed. The x's are not. Okay, so we have a few things we need to do. First thing I'm going to do is I'm going to rewrite it. I'm going to group all the x's together, and I'm going to factor a 4 out of them. Any question on that step? So I just factored a 4 out and grouped the x's together. I'm going to group the y's together, but there's nothing I need to factor out because it already has a 1 in front. So it's y squared plus 4y. Okay, and move the 4 to the other side. Okay, notice I left a little bit of space at the end of each of the trinomials. That's because we're going to add a number to both of them to complete the square. Okay, anyone remember how you find that number you add? It's 2 steps. And it works out particularly nice if you have an even number here, because you won't get a decimal. Yep?
So you have to take half of that, what we know as the 2, so that would end up being 1, and then you have to square it. But because you factored out a 4, you have to multiply that 4.
Yep, so everything she said is perfect. Just make sure you include the negative when you take half of it. Now when you square it, yes, the negative is just going to go away anyway. So we take half of negative 2, which is negative 1, square it, and negative 1 squared is 1. Okay, so perfect. Do the same thing here. Take half of 4 is 2, and square it. You get 4. Now we have to go back, okay, as Marina just said, be very careful. What did I add in total to the left-hand side? Whatever I added on the left, I also have to add to the right. Yep.
Technically, you added 4 because you're multiplying 4 by 1 when you distribute the 4.
So we added a total of 4 on the left side. Not quite 4. I agree with everything you said, though, except the amount we added. Yep.
You added 8
8. Yeah, why did we add 8?
because you add 4 to the x's and 4 to the y's.
Yeah, Marina explained the first part. We added 4 times 1. We added 4 in this trinomial, plus 4 in this trinomial. So we added 8 on the left. So we need to add 8 on the right. Okay, that's the part some people forget. When you have a number in front and you add something, you didn't really add 1. You added 4 times that. Okay? All right, so next part. Let's write down what this would factor as. What does x squared minus 2x plus 1 factor as? Yeah?
X minus 1.
Squared, right? Yeah. X minus 1 squared. Plus, how about Brian? What's y squared plus 4y plus 4? How would that factor?
Be y plus 2.
So y plus 2 times y plus 2. Okay, then on the other side, negative 4 plus 8 is 4. Now we almost have this in the form we want. We've got a binomial squared, we've got a binomial squared. Just one thing that's wrong with it. Yep.
Divide by 4.
Right, divide everything by 4 so we get it equal to 1. And that'll give us our equation. So we've got x minus 1 squared over 1 plus y plus 2 squared over 4 equals 1. Okay, now remember what they were actually asking us to do. Discuss. Those steps we just did, that's not our final answer. That's just so now we can look at it, and now we can discuss it. It should be very easy to find A, B, H, and K to describe everything they want. Okay, this is just explaining how to complete the square, if you forgot how to do that. Okay, be very careful when you tell me H and K here, okay, especially because of this plus sign. Okay, Michael, what's H?
-1.
So when you're looking for the coordinates of your center, you're just looking at the number that comes after the minus sign. Yeah, so H is 1. What about K?
-2.
That's -2. Okay, do not write K as 2. K is -2. Okay, A is square root of 4. B is the square root of 1. And C, well, it's going to come out to a messy answer. C squared equals A squared minus B squared. And so we get C as the square root of 3. Okay, so now let's describe the 4 things: the major axis, the center, the vertices, and the foci. Okay, Tahino, which way is my major axis going to go?
Vertical.
Yep. Bigger number is under y, so this means this ellipse is vertical. Okay, so major axis, vertical. Okay, it always helps to find the center next because everything else is based off the center. Okay. In this case, the foci will be C units above and below. The vertices, A units above and below. Okay, so let's find our center. Brandon, what's my center?
1, -2.
Good. 1, -2. Okay, foci. All right, we're going to be above and below the center because the major axis is vertical. All right. So when I'm going above and below this coordinate, don't mess with the x values. If we want to go above the center, square root 3 units, you just take -2 plus square root 3. If you want to go below the center, C units, it'd be -2 minus square root 3. If you'd like to write both answers separate, you can. I'm just going to combine them together like that. Everyone understand why I added and subtracted to the y value, not the x value? Because we're going above and below the center. Okay, and my vertices. Okay, this one, the coordinates should work out much nicer because we don't have to deal with that square root. Okay, again, just like the foci, vertices are going to be above and below the center. Sam, how many units above and below the center are we going to go to find our vertices?
2.
Yeah. A tells us how far from the center we're going to be. We're 2 units away from the center. Okay, to look at our center, how about, Tahina, if I go 2 units above this, what would be the coordinates of that?
1, 0.
Yeah. 1, 0. And how about Shannon? If I go 2 units below that, where would I be? 1, -4. And that's everything they want. That's probably the hardest kind of problem. You got to complete the square twice, and then you can discuss everything. Okay, so any questions on ellipses? Okay, so that's the kind of problems you'll see in the homework. I do have some graph paper. I don't think there's that many graphs, though. I think the graphs are mostly matching. Mostly matching. It's on 397. I'd like you to try 13 to 17 all. Those are all matching, except 17. So 13 through 16 is matching. 21. 27 to 31. I would grab a piece of graph paper for that section. 39 and 41. 43 to 47 odd, and 55. Okay, so we'll take a look at that tomorrow, and then we'll finish conic sections with the hyperbole.